Hey 11s, this is exercise 10D on applications to probability on page 382 of your textbook. Now, over the last couple of lessons, we've been looking at counting methods. So, for example, permutations and also combinations, and hopefully you guys are quite familiar with how to apply them. Now, speaking of applying them, today we're going to be looking at how we can apply counting methods in relevance to probability in order to find the probability of a certain event that may be a lot more difficult to solve than just, for example, rolling a dice or flipping a coin. Now, before we get into that, I do want to very briefly mention how to use combinations and permutations on the ClassPad calculator. So on the left-hand side here, I've included some screenshots of what your calculator looks like. So you can see on the top left, we've got an image of what your screen looks like when you press the keyboard button. What I want you to do is I want you to press the down arrow. And once you press the down arrow, you'll end up with this screen here. Okay. Now this screen here we can see has the screen that has catalog, advanced, and number. If you press the advanced key there, you'll end up with this screen on the bottom. On the bottom, you can see that on the right hand side, there's the three buttons I'm going to be using a lot for combinations, permutations, and factorials. So of course, the first value here, the first button there gives us the factorial. So if you want to just calculate, for example, 52 factorial, that's the button you're going to go for. Just type in 52 and then the exclamation mark, and you'll end up with the answer there. NPR and NCR is what we're going to be focusing on. So for example, if you want to calculate the permutation when n equals to 5 and r equals to 2, I'm just selecting random numbers. When you press the calculator's NPR button, it shows you this screen here, and then you have to type in certain values. Just note the first value is always going to be n and the second value is going to be r, and you have to type those values in. So in our situation of 5p2, we're going to type in npr bracket 5, 2. Awesome, let's get into today's content. Here we go. So with applications of probability, we can now count the total number of outcomes given to a particular experiment, where the probability of an event occurring is worked out by dividing the number of outcomes in the event by the total number of possible outcomes. Now I bring this up, I'm going to move this to the right hand side so you guys can see the different steps involved. So just to keep it concise, first you find out how many total possibilities there are. In other words, use your counting method. 2, you're going to go ahead and find the number of outcomes in your specific event. So just like with normal probability, we divide the number of specific events. So for example, if you're trying to roll a 3 on a dice, it's 1 because it's 1 out of 6 for the 3. So it's an event of 1 divided by the total number of possibilities, 6. So in this situation, we're just working with different values that are significantly larger than rolling a dice. Okay, let's jump into an example with this one over here where we can see that 4 letters, creating a 4-letter word, and we have to make them by arranging letters of the word special. So we're picking letters from this in order to create 4-letter words. Now, what is the probability that the word will start with a vowel? So I'm going to go ahead and follow the instructions here. The first step is to determine the total number of possible outcomes. So to find the total number of possible outcomes, I'm going to go ahead and try and find how many possible options there are. So for the word special, there are no repeats, and there's a total of 7 letters. So in the first gap, I know that total equals to, now the first spot in my 4-letter word is going to be 1 of 7, and then 1 of 6, 1 of 5, and 1 of 4 different letters. If this seems quite unfamiliar to you, please go back and watch the videos on exercise 10B and exercise 10C. Awesome. Solving that gives us an answer of 840. Now we're not finished yet because we need to find the probability that the word is a vowel. So remember, a vowel, of course, we know is going to be one of either the E, I, or A. With that in mind, of course, our first spot is going to be 1 of 3. It's going to be 1 of 3. Now, if we continue thinking about this, well, what is the number of letters available that we can choose from for the second spot in our word? Well, there's 6 letters left, and then 5, and then 4. So we end up with a value of 360. Now, once we've found that, we need to follow the last step, which is to find the required probability by dividing the number of outcomes by the by the total number of outcomes. Now that's spelled incorrectly, but you get the point. So I'm going to divide val, so the probability of val, and now technically I should be writing starts with the val, but you get the point, is 360 divided by 840, which is our total, which simplifies to give us 3 out of 7. Okay. Now let's go ahead and look at this next question. This next question is a little bit more difficult and will require a little bit more thinking. So 3 students are to be chosen to represent the class in a debate. If the class consists of 6 boys and 4 girls, what is the probability that the team will contain exactly 1 girl? So for this one, what I'm going to do is I'm going to actually try and figure out what is the probability, what are the different possibilities, and then what are the different number of outcomes for each of those. So I'm going to go do this on the right hand side so we can see it a bit clearer. Now of course you know there are 6 boys, so I'm going to go ahead and write 6b, and there are 4 girls. Now if we're choosing 3 students, let's try and figure out every combination possible. Right, of course we're using combinations because it doesn't say anything about order, does it? So if we're looking at combinations, well, we know that the first possibility, of course, is that they're all girls. So if it's 0 boys and 1 girl, well, how would we solve that? Well, we know it's and, of course, so we use the multiplication principle. We multiply the values together. So to get 0 boys and 1 girl, so not 1 girl, my apologies, I mean 3 girls, because we're a total of 3 students. To get that, well, we say, okay, well, 6C0, because 6C0 gives us, well, the total of 6 students, or 6 boys to be specific, with 0 of them in the group, and I multiply them by 4C3, because I'm saying there's a total of 4 girls, and we're selecting 3 of them. Now, solving that gives me an answer of 4. You're more than welcome to use a calculator or do that by hand. Now, another possibility is what if I have 1 boy and 2 girls? We still have a collective 3 students, but now we have to use a different calculation. So instead of saying 6C0, now the 6 stays the same. We still have 6 boys, a total to pick from, but there's only 1 that we're going to end up choosing. So it's 6C1 multiplied by, now the 4 stays the same, so 4C2, because we're choosing 2 girls, and that gives us an answer of 36. Hopefully you get the idea. Now what happens if I have 2 boys? And I multiply them, 2 boys and 1 girl, gives me 6C2. I'm going to fly through these because I'm hoping that you guys are able to pick up what I'm putting down. That gives me an answer of 60. And finally, if I have 3 boys and 0 girls, well, that gives me 6C3 multiplied by 4C0, which gives me an answer of 20. Now, if I ask you, how many different possibilities are there? Well, that is every possibility, isn't it? I can do all of that and then end up with a total of 120. So because I've done every single possible option, we know that the total number of outcomes for anything when there's no restrictions whatsoever, except for the fact that there are 3 students that we're picking, is 120 outcomes. Now, there's another way we could have done this. We could have just ignored the fact that there are 6 boys and 4 girls, and just said there were 10 students. So we could have just said 10C3. 10 students to pick from, and we're only picking 3. Which if you put in the calculator, will give you 120 anyway. But we drew out the entire thing on purpose so that we can refer back to this. So we know that if we're trying to find the probability of anything, it's going to be divided by 120 to give us a proper probability. Now, if we're trying to find the probability that the team will contain exactly 1 girl, what I'm going to do is I'm going to refer back to this. I know that 1 girl is this value right here, or this row I should say, which gives me a value of 60. So there's 60 situations where the answer is 1 girl. And so I'm going to go ahead and write 60 over 120, which simplifies to half. Now to find the probability of at least 2 girls, well, I know to find at least 2 girls, I need to have 2 girls or 3 girls. And if it's or, then obviously we add them together. So we're going to focus on these 2 rows over here. because both of them have where we have at least 2 girls. We add them together, so we have 4 plus 36 divided by a total of 120. That simplifies to 1 out of 3. So that's it for today's content. I know it's quite a bit to go through. Let me know if you have any questions. Otherwise, best of luck with exercise 10D.